Hello everyone, my name is Yang Chongdin, a computer science student. In this video, I will present my assignment for the computer system subject. The task was to build a tennis scoreboard using Logisim, divided into 5 stages. Let's go through each stage. In stage 1, I built a switching server. There are 2 players, player 1 and player 2, with a LED indicates which player is serving. By default, player 1 serves, and pressing the reset button brings it back to player 1. I used a T flip-flop to handle the switch with a constant connect to T input. The switch server button here acts at the clock of the T flip-flop, and the reset button is linked to the reset input of T flip-flop. The output Q0 of flip-flop is connected to player 1 server LED, while Q connects to player 2 LED. Okay, let's see how this works. And reset, it will change to player 1 by default. Let's move on to stage 2. In this stage, I built the game score. When clicking increment button, it lights up 1 LED at a time up to 6 LEDs. After that, clicking again will reset on LEDs. I use 7 D flip-flops, 6 for 6 LEDs, and the last one for reset signal. Okay. The first flip-flop has a constant connected to D input, while the others are linked to the Q output of the previous flip-flop. I also use an AND gate here to detect when all LEDs are on and trigger the reset. I use increment button at the clock of on D flip-flop. Okay, let's test it. Okay, and reset. In this stage, I built the board score. The circuit scales from 000 to 001, meaning that's from 0 to 4. I used 3 JK flip-flops connecting to a constant to post J and K inputs. The increments button here acts at the clock for the first flip-flop, and the next flip-flops are triggered by the Q outputs from the previous one. To ensure that count stops at 4, I use an AND gate here to detect the 101 state and reset the flip-flops. Okay, let me show how this works. Okay, 1, 2, 3, 4, and reset. 1, 2, 3, 4, and reset. Okay, and reset at the main. In this stage, I connected the output from stage 3 to display the 7-segment sequence. The input combinations 0, 0, 0 to 0, 0, 1 correspond to scores 0, 15, 30, 40, and 80. I created a table like that and derived a Boolean expression for each segment. Then I built the circuitries using similar outputs to state gates. Okay, let me show how this works. 0, 15, 30, 40, 80, and reset to 0, 0. Okay, and reset. Stage 5, I added the decreasement button for both the game score and the board score. This button allows the score to decrease through the previous value, but when the value reaches 0, it stays at 0 and does not decrease further. For the board score, I used 3 additional D flip-flops to store the previous states from the JK flip-flop. The D flip-flops use the same clock as the JK flip-flops to ensure that the data is stored correctly. For example, when the current output is 1, 0, 0, it will store 0, 0, 0, and 1 is 0, 1, 0, it will store 1, 0, 0. Okay, to prevent the score from decreasing below 0, I connected the output of the last D flip-flop here to the reset input of on D flip-flops. This ensures that when the output is 0, 0, it stays there even if the decreasement button is pressed. To update the display correctly, I connected to the D flip-flop outputs to the set and reset inputs of the JK flip-flop here. If the D flip-flop is 1, it sets the JK flip-flop to 1. If it's 0, it resets to 0. The decreasement button as the animal signal for this update. Okay, let's test this. Okay. Decrease 1. And when it's 0, it cannot decrease anymore. For the game score, the approach is similar. The D flip-flop output restores the previous game state will be used to reset the right mode LED. This ensures that the game score decreases correctly and doesn't loop back when it reaches 0. Okay, let me demonstrate how the decreasement button works for game score. Decrease 1. Decrease 1. When on LEDs up, it cannot decrease anymore. Okay, that's the complete functionality of my tennis scoreboard. Thank you for watching.